to get into our papers. So first up, oh, let's double check.
Yeah, I didn't do it.
Yeah, no, I understand. Can we get the slides back? First up, let's resolve our AV problems.
Right, yeah.
And then, what's up?
Can I run it, because I have time there, you know, can I start it?
Yeah, sure, you do whatever you want. So first up, we have Jan, who's going to be presenting Don't Call Us, We'll Call You.
Okay. Hello, everyone. My name is Jan Verter. I'm from Charles University at Prague, and I'm going to be hunching over a little bit. Oh, I can actually. Well, I'm going to be hunching over.
You can take it.
Okay. Yeah, sure. I think I'm going to be doing some juggling then. Thank you. So, yeah, this is our paper, the title of it. The modern programming is much more than writing code. I think we have seen that in the keynote. Actually, that couldn't work out better. And programming languages have all sorts of interesting and creative ways of writing the source code itself. And we want to explore that kind of space for writing proofs as well. Some of those concepts mentioned on the slides have their counterparts in the proof assistance world. Some of them might not. In any case, this is the overall idea, direction that has inspired us. So we are in the very early stages of the research. The paper was actually submitted at, well, after only a couple of months of me doing my PhD. We have a working prototype that is described in the, well, used for the paper. However, I want to go beyond that during this talk. And also, I won't really be using or showing the prototype because it uses, well, unconventional notation that is not very slide-friendly, like this. You know, it's the fish style or flex style notation for natural deduction. So instead, I will make pretend a different, more readable presentation using only the slides and the power of imagination, mostly from you. I'm going to leverage that. So we want to explore a different way of interacting with the proof, with the tool used for writing proofs, doing proving, or maybe a different approach to thinking about proving or writing proofs. We want a tool operating on specifically two modes into specific modes. The first kind of interaction is is supposed to be directed by the tool itself. The tool is sort of a narrator of the process. The process is carried out by the tool doing the auto-search, auto-searching for the proof, and making the user sort of a supervisor of the tool and its search strategy, whatever it is. Whenever the tool would fail proving or continuing proving, it can request help from the user. That's kind of the difference, or the idea, the key idea. The role of the user at that point becomes to figure out what went wrong during the auto search and help the tool with the proof, finishing the proof perhaps. And the role of the tool is to explain to the user what it tried, why it tried it, and do that as clearly as possible. The other kind of interaction is when the user wants to write the proof themselves, as is like more usual. They want to do that from the very beginning. I personally relate this mode to sort of a pair programming session, the user being the pilot, deciding on the direction and ideas, the tool being the co-pilot, trying to be helpful, providing possible suggestions and whatnot. I have an example that I mentioned. So let's see it in action on a simple example. It's a simple example in theory of natural numbers. So we have natural numbers defined. We, in a very standard way, we also have one judgment form addition for addition relation. That is also pretty much standard, I think. And that's mostly, that's almost all we'll need throughout the example. So this is the theorem that I'm going to use for the example. The theorem states that for every two numbers there's a third one such that both is true. The first number plus the second number equals 2 and 3. The third number and the second number plus the first number equals to the third number. So the addition is both commutative and total. I guess we might usually think of the two separate theorems, but let's say this is a homework assignment or something like that. It doesn't really matter. All right, so this is the make pretend powered by your imagination user interface. So let's say we may want to start in the automatic search mode, simply because the theorem itself is simple. It doesn't seem to be too complicated, require much work. And we want to skip on as much work as possible, leaving the hard work for the tool. So we start by writing a term, a special command, if you will, it's the proof thing, that triggers the automatic search. And this initiates the automatic proof search as it should, and it fails immediately, which is sort of what we want. You know, the tool does a little bit of work behind the scene, but it fails for the user, from the perspective of the user, it fails immediately, which is what we want, because it can't prove the whole theorem for whatever reason. So all we knew at this point is the tool tried something, we don't know what yet. However, we know that it failed. We will have to try to help it. The key question for the user of the tool, so for us, I guess, is where it failed and why. You know, what it did, why what it did was not enough, was not okay. Another question, sort of for us as researchers, is whether the user can be made understand what has been tried, identify at the right place, at the right time, identify the correct and also incorrect approaches that the tool could take, and help finish the tool. Well, help the tool finish the proof successfully. So at this moment precisely, I'm going to be extending what is written in the paper. It's just so you know. After we submitted, we had some ideas that maybe, we had some ideas. So the tool now it comes the explaining. Now the tool is going to try to explain to me as clearly as possible, hopefully, what is happening, what it tried to do. So it tells me that it tried to use induction on the first universal variable, and we can also see the proof term being generated, at least the structure of it. Both contents of the branches are actually abstracted now, abstracted away. They are hidden behind the proof command. That's because, well, if just one of them sort of failed to lead to success, but the other one, the simpler one, the zero case, was proved successfully by the tool, then there's really no reason to generate the whole proof, to show the user the parts that are uninteresting because they didn't lead to failure. So the tool will only expand the parts that led to the state where it got stuck. Just a note about the magical, powered by imagination user interface. I'm going to make bold the parts that are sort of like new from the previous slide, just so that you can orient a little bit better. And I'm going to underscore the goal that is currently selected. You know, pretty standard stuff from like proof assistants like Coq or whatnot, where you have goals in a queue. So we have the currently selected goal is the body of the branch, where the content of the branch, when the first number would be successor of some number, capital N1. Yeah. Now, the first one, yeah, as I said, I'm just going to reiterate, the first branch is going to stay like this for the rest of the talk, because it's been successfully proved, so it doesn't need to be shown to the user. So next we see that the tool tried to do case analysis on the second number. We also see the more structure of the proof that it generated. And at this point, we get stuck. Well, yeah, the tool gets stuck. Now, this is the point where the user should help. Now, it's not really terribly relevant why just now. I guess it all depends on like how the automatic strategy is configured and other factors. I am sure that we can figure out a simple strategy that would be able to prove the whole theorem. That is beside the point, because even a different, simple strategy that would be able to figure out this theorem would fail somewhere else on some other theorem, on some other example. So let's just, let's fail within the simple territory and see how we can do with that. Right. So yeah, let's just consider this situation and see what happens. So what we need to do, also, sorry, I'm going to go back one slide. The command that I enter next is saying like, I want to write the proof. I want to help the tool now. I'm entering the stage where I'm no longer just waiting, and I'm no longer sort of like consuming the narrative of the narrator. I'm going to do some work. So what I need to do is, in this specific example, I need to use the induction hypothesis correctly. That's from the induction on the first variable. Maybe the tool didn't know to do that. Maybe the tool has a different reason why it failed. It's not terribly important. So just a few details. I want to use the induction hypothesis by instantiating the universal variable from it with successor of the capital N2, and use that resulting existential statement to prove the goal that I'm supposed to be proving. That's just how the proof goes. It's a simple proof. So we add those two, or rather three relevant lines. The second line is a little bit busy. However, it's actually not that complicated. It's just a syntax for saying that I'm using the existential from the line before. That's the one that is justified by induction hypothesis. So I'm using that. I'm going to be referring to that specific, like I'm instantiating the existential variable with a constant capital N3. And within the scope, so that's the indentation doing. Now I have access to that assumption. Right. Now, because I've written that, maybe it just so happens that the search strategy, the configuration, the capability of the tool is enough at this point, and I could just write the proof command and let the tool again enter the automatic mode, let it figure out the rest. Suppose that it would. I think that would be nice. We didn't really have to do much work. It's a simple theorem again, but still, it's nice to not do so much work. However, I don't want to finish just yet. I want to show you the other mode as well. So instead of proof, I'm gonna write proof interactive, which is a variation of the proof. It just says, now I'm entering the other mode in which I actually want to be the pilot, and the tool is supposed to be my co-pilot. It's supposed to help me. That is just to say, the tool becomes a proof assistant that tries to use its ability to do the auto search in a way that will sort of like recommend me the next step if it ever can. So that's what happens next. I can see the current goal being still the same statement as before, except I have, you know, something in the scope that is going to help me later with that. The tool tells me that the matching action for dealing with that goal would be to, well, instantiate the existential, find any such entry, any term that would satisfy the statement. So I do just that. I proceed, and the tool gives me 2 more lines. The last one is just constructing the statement. The last one is just saying, if I were to find some entry, you know, I would be able to generalize it. I would be able to say, well, there is some, because I've found one. The line before is the line that is sort of doing something interesting. That line is our current goal also, because that's the interesting part. We can see the placeholder variable. That's the one with the question mark. I have to find that. The placeholder is not really sort of like syntactically valid part of the proof. However, because we are in an interactive environment, because the tool allows me to, you know, write the proof and sort of like find it, then when we find the term that would be fitting there, all the placeholders get replaced and the proof becomes syntactically valid again. We are recommended to proceed by splitting the current goal, which is a conjunction. So we would split the conjunction. We would prove the left part, the right part. We do that because I think we find that step sensible. We get 2 more lines, 2 more sub-goals. And at this point, I'm going to fast forward a little bit because I'm running out of time, which I've anticipated. I'm fast forwarding because at this point, I'm going to be generating quite a bit of code. The thing is, the notation is quite, verbose. It's quite verbose. It is actually by design, at least at this point. I may end up being able to address that in the end, maybe not. The point is, the important part is the placeholders being replaced. There are no more placeholders. It actually so happens that the term that is supposed to go for the placeholder is called capital N3. That's why I named the placeholder that way, to minimize the disconnect, you know. And we can see that there are no more goals and the proof is done. Right. So to recapitulate, we are currently working with 2 modes of interaction. One that puts the user into a supervising position, the tool into sort of like narrating position, and the user is only summoned by the tool if the tool fails at something, at proving, right, at searching for the proof. The other mode allows them to take the lead, take the steering wheel, and use the help of the tool while deciding what the next step is going to be. Also, you may have noticed that the 2 modes sort of don't seem that dissimilar. That is correct. They are actually based on the same underlying sort of facility or infrastructure. It's the automated proof search. Either the tool does the work behind the scenes, or it does the search while the user is deciding what is going to happen. Regarding the similarity of the two modes, we find it a desirable design at this point in time. We think that maybe in the future versions of the tool, which are being developed, well, which one version is being developed, a powerful UI, or like a different UI could enable even more modes, perhaps, who knows. I think it could be considered an elegant sort of design that just so happened kind of on its own. There are some questions, challenges and opportunities that we have found so far. For instance, the search, when in automated mode, it can take a wrong turn. Then, like, how do you correctly explain to the user what it tried to do, why it tried to do that, what if it's way too deep, way too many steps on the wrong path. Another question would be how to explain the user what the tool did at all. You know, even if it did the right thing, why? You know. A little bit different question is how to make the search configurable, because like we are not really interested in like studying the methods of automated reasoning. We want to sort of like work around that by doing having a framework that requires configuration for the auto search. Then the question is, how do you make it configurable enough so that it can deal with many goals, many statements, many shapes, but also not too involved. So we are exploring those questions. We think that a nice graphical interface could help with solving most of them, where you would sort of be able to explore, to wander around the proof, you know, maybe like follow the linear structure of the proof, if there's one, the linear sort of like story, but also not. So to summarize, we have a prototype. We are actually working on a new version at this point of the tool that works in two main modes of interaction. We want to explore the side of interactivity where the tool is the initiator and the user poses as a supervisor when deals with conflicts or failures. Our design builds on one shared facility of those, and those two modes exist as a way to sort of like to think or to interact with the tool. And we are currently exploring the path in which, when the auto search fails and is tasked with explaining what it did and why it did that, how it did that, we are taking the sort of like human way approach, where it's very similar to what happens when a student comes to a teacher asking like what they did wrong. The teacher would usually have to start from the very beginning, or at least from the point where sort of like they left the picture. Okay, so that's it. Thank you for your attention.
All right. Thank you for the excellent talk. And now it's time to call on the audience to get some questions. But before we do that, I just want to briefly point out, are you using a switch controller as a means of controlling your presentation?
Yes.
That's amazing. Yeah, shout out. That's. Why did I pay for one? Okay. Anyways, questions.
Thanks for the talk. So if you ask two people to work together on a task, then they'll be forced to communicate about the task. Right? If one gets stuck, then the other can give advice, and they're communicating about task state and ideas. And have you thought about using that observation as a way of getting data with which you could ground your design? Right? You could ask participants in a study, please work together to write these proofs, and then look at the kinds of information they communicate and how they communicate that information.
Yeah. Yeah. Thank you. My supervisor is pushing me towards something like that. We we didn't do that before writing the paper. For one reason would be, well, okay, so you didn't ask why we didn't do that, but you. Anyways, we didn't do that yet. But yes, my supervisor is telling me to do that. I'm kind of worried because I don't usually work with, I don't usually do studies. I never do studies. I've never done studies. So, but I'm very much interested in what would happen if, what would be learned. Thank you.
Hi. Sorry if you said this before, but what kind of infrastructure is this built on? Like, what kind of a language? Is it like Agda, or is it your own thing?
Right. Yeah. Currently, or the prototype is our own thing.
Okay.
The reason is just that it was quicker to hack something together.
Okay, so I'm asking this because there's some existing work on this. There's like Auto in Agda that is trying to do like proof search in Agda holes, like for whole different developments. And also like based on that, I sort of extended that from my master's thesis. It's called edit time tactics, in which you can implement your own proof search mechanism, and you can implement it in a way that can like get stuck and give feedback. There's one thing. Something else that I implemented is you can do. Like it's an underproof assistant for horologic proofs and sequence calculus proofs, in which you have like an automated system that goes as far as it goes, and then asks for user input. Or you can alternatively try to leave everything to the students. It was like an educated setting. So I think maybe we should look into some of that existing work, and maybe we should talk.
Yeah, I would very much like to do that. Thank you.
Really interesting work. I look forward to seeing where it goes. One of the things I like about an interactive manual mode is that there might be more than one way to prove something.
Yeah.
And if you don't care just about the proof, but you also care about presenting it and giving people the intuition for why it's true, then you might care about which way it goes. I'm wondering if just even beyond recognition over recall, if there might be even more connections between these modes. For example, maybe there's several choices I could make manually, but would it affect my decision if I knew that the tool could automatically prove one of those directions? Maybe it's more promising.
Yeah, thank you. And yeah, I think that's a really interesting perspective. Thank you for that.
Thanks for the talk, super cool. Have you thought about what happens once you're done? Can you recover the full proof? Because if you have like branches that are done with like a proof, maybe you actually want to get a proper proof script in the end.
Yeah, thank you for the question. It's very much supposed to be done in a way where the tool actually allows you to do that, just because it's hidden behind the proof command. The tool at some point had to construct the whole proof. This is actually one of the interesting challenges that didn't make it to the slide, because there's a big question of like whether you wanna whether you wanna put the proof. Do you maybe want to just export the proof for when you really want to see it, or do you make the default behavior be showing the proof, constructing the proof, and putting it somewhere at all times? Then do you want to, does that mean that your own code gets rewritten? Sort of like the approach we are taking is very much inspired by the live programming. So I think the keynote was actually very relevant, because I was thinking about it from a perspective of the proof being a live object. Now that begs the question, like, if you rewrite the proof, if you rewrite my live object, then when I share it with someone else, they no longer have to run the automated search because there's no automation. So it's an interesting space full of decisions. Thank you.
All right, we have time for one more question. Can the next speaker go ahead and go up and start getting their laptop in? And then last question.
Yeah, James Noble. Yeah, I figure I've suffered long-term cognitive damage, not just from COVID, but also from Daphne. I guess that's a sentiment that is surprisingly widely shared in the room. Now, one of the things Daphne does is its proof objects are completely implicit. There's no way to manipulate them. You don't construct them explicitly. It uses Z3 to find these things, and the only interaction really that you have with the tool are all in terms of the source program.
You have to go.
So I don't know whether you think, I mean, there are a bunch of issues with Daphne. I don't know whether you think that's a good approach or whether you think it's necessary to actually explicitly have the representation of the proof and then be able for users to manipulate that directly.
Right. Yeah, thank you.
I don't know, I did sort of phrase it as a question, but anyway.
Yeah. It's okay, because actually this is very much one of the questions. It's a perspective that I've spent a lot of time thinking about. I don't really want to say if what I think about like other tools, what they are doing, but for me, I feel like the direction that I want to take would make the explicit existence of the proof object sort of necessary, because the user would be interacting with it in sort of like live programming / proving way, and I don't want to hide anything. I want them to be able to sort of like, I said, I'm not going to show you the part of the case, of the branch, the case for 0, because it's trivial, the tool figure it out, whatever, who cares? But I don't really want to prohibit you from, as a user, deciding that, well, I no longer want to spend time, being explained what the tool did at this point. I want to go my own way and see what it did here. It's so smart, it thinks, that it knows better and proved this thing. I don't think it, did it correctly and all that. So for that, I need the existence of the proof object at all times. I need it to be able, I need it sort of like close. It needs to be available immediately. So, yeah, thank you.
Great, and thank you for that great presentation.
Thank you.